In this lesson, we will be learning how to identify and generate geometric patterns. There are patterns everywhere. In nature, you will see them in plants or animals, and even in weather. In math, just like in nature, patterns can take many shapes. For example, you could see a sequence of geometric shapes such as this, or you could see a design that increases as it continues from term to term, or you can also see a sequence of numbers. No matter what type of pattern you are dealing with, in order to generate them or extend them, you have to become a pattern investigator, or PI. So in order to become a good PI, you're going to have to look at each pattern very carefully and look for what changes. So here we have a sequence of geometric shapes. What we're going to look for is the pattern core. The pattern core is the shapes that continue before the sequence starts to repeat itself. So here I have 2 red circles, then 1 blue square, then 2 green stars, and then I begin again with 2 red circles, 1 blue square, and 2 green stars. So I can deduce that this is the pattern core because this is where it begins to repeat itself. So if I look, I can see that the core or the sequence repeats itself here, and then it begins to start again, but it doesn't get very far before I get to this variable that I am missing. So I'm going to look back at my pattern core to figure out what I want to place in that blank spot. So I look at the first step in my pattern and I have a red circle. I have my red circle here. Now I'm going to look at the second step in my pattern and I have another red circle. Here is where my missing variable goes. So I can deduce that my missing shape is going to be the red circle. Now here you see a different type of pattern. Again, I'm using geometric shapes, but it looks different because my steps are different. This is step 1, and step 1 includes 3 different shapes. This is step 2, and this is step 3. And as you can see that as the steps increase, so do the number of shapes. However, they don't all increase at the same rate necessarily. So I have to look at each shape individually, and I'm going to start here with the green circle. So if I look at the green circle, in step 1 I have 1, in step 2 I have 2, which would lend me to think that I was adding 1, and in step 3 I have 3, which again, if I added 1 to 2, I would get 3. So I can deduce that my rule for my green circle is to add 1. So in my step 4, I would add 1 to the 3, and that should tell me that I should have 4 green circles in my step 4. Now I can look at my blue square. Now my first step, my blue square, there is 1, so I might think that it is going to follow the same pattern or the same rule of adding 1. But as I look at the change from 2 to 4, that 1 doesn't hold up, because if I were to add 1, I wouldn't get 4 here, I would get 3. So I'm going to have to re-look at my rule. And there is another way that I can get from 1 blue square to 2. I can multiply by 2. And if I look at my 2 blue squares and I were to multiply that by 2, I would indeed get 4. So I can deduce that my rule for the blue square is to multiply by 2. And if I were to multiply the 4 blue squares that I have in step 3, that tells me that I should have 8 blue squares in step 4. Now, for the third and final piece, I'm going to be looking at my red star. In step 1, I have 1 red star, and in step 2, I have 3 red stars. So there are 2 ways that I could get there. I could add 2, or I could multiply by 3. So now I have to look at how I'm going to get from 3 to what I have here is 5. So logically, if I look at it, I could add 2 to 3 and I would get 5. So I can deduce that my rule for the stars is to add 2. Now, if I were to add 2 to the 5 stars that I have here, my fourth step should have 7 stars. So it's important to remember not to just assume that each of those geometric shapes are going to increase at the same level. I have to look at each one individually. Now, when I'm presented with shapes that follow this sequence, I have to really look at what they have in common. First of all, they are all polygons, which means they are closed two-dimensional figures. And they all have straight sides. So I can look at those features to determine what they have in common or what they might be changing as I move forward. So if I look at this first item, I know it's a triangle, and if I look at the triangle, I'm going to look at the sides, and I have 1, 2, 3 sides. And if I move to the next figure, I'm looking at a square, and I have 1, 2, 3, 4 sides. And if I look at the next figure, I'm looking at a pentagon, and it has 1, 2, 3, 4, 5 sides. And if I'm looking at the next figure, I have a hexagon, and it has 1, 2, 3, 4, 5, 6 sides. So it would be logical to think that my next figure would have 7 sides and would be a heptagon. Now, both of these figures are heptagons. Even though they look very different, the arrow is 1, 2, 3, 4, 5, 6, 7 sides, and this one has 1, 2, 3, 4, 5, 6, 7 sides as well. Now, in many cases, both of these would be acceptable answers. However, if I were given the choice between these two figures, there is another thing in common that these shapes have that would help me to determine which of these would be the correct next figure. The additional thing is all of these shapes are regular polygons. Because regular polygons means that all sides have the same length, then if I were to look at these two figures, only one of them has 7 sides, but all sides are the same length. So the answer to this one would be the regular heptagon. Sometimes I might be asked to create a pattern given certain criteria. For example, you will see here it says create an ABBC pattern. And although they are using variables or the letters A, B, and C, it's really telling us what to look for in our pattern. So each pattern core has 1, 2, 3, 4 items in it. And the first item, as you can see, since I only have one A, would need to have one of the first item. The second item, represented by B, would mean you would have to have 2 of the items. And the third item, represented by C, means you would only have to have 1 of those items before you would repeat the entire pattern again. You could choose whatever figures you would like to use. And for this example, I have used circles, squares, and stars, and I kept them all the same color so you can identify what actually changed. So I have 1 circle matching the 1A, I have 2 squares matching the 2 B's, and I have 1 star matching the 1 C. And then I begin to repeat my pattern. So really you're just looking for this as an instruction manual to tell you how to build your pattern. Now it's time for you to try one on your own. Here I have a pattern, an item that changes with each step. This is our first step, this is the second step, and this is the third step. I would like for you to pause the video while you try to figure out what the fourth step should look like. Please write down your answer or draw it on a whiteboard so that way we can compare. Go ahead and pause the video. Hopefully you were able to find your answer and you were able to identify that this item increased not only vertically but also horizontally and not necessarily at the same rate. So as I was looking here, as I went from step 1 to step 2, I added 1 block vertically, and then as I went from step 2 to step 3, I added another block, so I can see that I was adding 1 each time. And that tells me that in step 4, I should add another block, which is going to give me 3 blocks vertically. Now if I'm looking at the horizontal, as I moved from step 1 to step 2, I added 2 blocks. And as I moved from step 2 to step 3, I added 2 more blocks. So horizontally, I was adding 2 blocks to each one. Therefore, my final answer should have 3 blocks vertically added onto my original, and then 6 blocks horizontally, giving me this figure. I hope you had the right answer. In this video, we learned how to identify and generate geometric patterns.